All right, let's talk about those time and work problems. You know the ones, right? They pop up on exams, look super simple, but then, boom, there's a hidden trap. Well, today we are going to crack the code on these for good.
Okay, so first things first, let's dive right into the classic trap, the one that gets almost everybody. So here we go. A can do a job in 10 days, B in 15. If they work together, how long does it take? Now be honest, what's your first instinct? For most people, the brain immediately goes to this.
You want to average the times, right? 10 plus 15 divided by 2, 12.5 days. It just seems so logical, but nope, it's a total trap. The actual answer is 6 days, way less. And this just proves the #1 rule right off the bat. You can't just add or average the time it takes.
So what's the secret? How do you get it right every single time? Well, the good news is there's a kind of master key, a single method that doesn't just unlock this one problem, but pretty much every version of it you'll ever see.
Okay, so here's our roadmap for today. We've already seen the common trap. Next up, we'll talk about thinking and efficiency. Then we'll get into the powerful LCM method. After that, we'll tackle pipes and leaks, handle some tricky scenarios, and wrap up with your key takeaway.
All right, section 2, thinking and efficiency. So if adding time is out, what's in? Well, this is where we need a big mental shift. We've got to stop focusing on the total number of days and start thinking about their daily work rate. In other words, their efficiency.
So what is efficiency? It's just the amount of work someone gets done in a single unit of time, like one day. So if someone can do a whole job in 10 days, that means every day they're knocking out 1/10 of it. That's their rate. Now, we can add those rates, but honestly, who wants to mess around with fractions? It's slow, and it's easy to make a mistake.
And that's the whole point, right? The key is to get rid of the fractions and make the problem concrete. We want to turn these abstract ideas into simple, whole numbers that are easy to work with.
Which brings us to the master key itself, the powerful LCM method. This is going to be your new best friend for these kinds of problems, I promise.
It's a really simple 3-step process. First, find the LCM of the times. This number becomes your total work, but think of it in units. Then you calculate each person's efficiency by dividing that total work by their time. And finally, you just plug it into the formula. Time equals total work divided by their combined efficiency. So instead of an abstract job, think of it as, a project to build a wall with 60 bricks. Efficiency just becomes how many bricks each person lays per day. Much easier to picture, right?
Now let's solve our original problem with this. The LCM of 10 and 15, that's 30. So let's say the total job is 30 units of work. To figure out A's efficiency, we just do 30 divided by 10 days, so A does 3 units a day. For B, it's 30 divided by 15 days, which is 2 units a day. So what's their combined efficiency? 3 plus 2, it's 5 units per day. See, no fractions anywhere, just clean, simple numbers.
And now the final step is a piece of cake. The total work is 30 units. They do 5 units a day together, so 30 divided by 5, that equals 6 days. And there it is, the right answer with simple arithmetic.
Now, what's really cool about this method is how versatile it is. It's not just for people building walls. We can use the exact same logic for another classic problem type: pipes, cisterns, and leaks.
There's really only one new thing to remember here, and it's super simple. An inlet pipe, one that's filling the tank, does positive work. An outlet pipe or a leak, one that's emptying the tank, does negative work. That's it. Plus and minus.
All right, let's try one. Pipe A fills the tank in 6 hours. Pipe B empties it in 8 hours. If they're both open, how long till the tank is full? Let's use our LCM method. What do you think the total work is going to be here?
Okay, the LCM of 6 and 8 is 24. So our total work is filling 24 units. Pipe A's efficiency is 24 divided by 6, which is plus 4 units per hour. Pipe B, on the other hand, is emptying, so its efficiency is 24 divided by 8, which is minus 3 units per hour. So what's the net effect? Plus 4 minus 3? They're only making progress at a rate of 1 unit per hour. So to fill all 24 units, it's going to take 24 hours.
All right, let's level up. What about those really tricky scenarios? Like when people work on alternate days or someone leaves halfway through. Well, the beauty of this system is that the core logic of efficiency, it still holds up.
So here's a common one. A takes 20 days, B takes 30. They work on alternate days, and A goes first. How long will it take? Now, the key here isn't some new complicated formula. It's just about thinking in terms of work cycles.
Let's break it down. The LCM of 20 and 30 is 60, so that's our total work. A's efficiency is 60 divided by 20, which is 3 units a day. B's is 60 by 30, so 2 units a day. Okay, on day 1, A works and gets 3 units done. On day 2, B works and gets 2 units done. So in one full cycle, which is 2 days long, they complete 5 units of work together. To get our total of 60 units done, how many of these 5-unit cycles do we need? 60 divided by 5, that's 12 cycles.
And that pretty much gives us the answer. We need 12 cycles, and each cycle is 2 days long, so 12 times 2, it's going to take exactly 24 days. See? The logic just works, no matter how tricky the setup seems.
Okay, so let's wrap this up. What is the key takeaway from all of this? What do you absolutely need to remember?
These are your golden rules. First, always convert time into a work rate or efficiency. Second, you add the rates, you never ever add the times. Third, use the LCM method to avoid fractions and keep the math simple. Remember that filling pipes are positive work and emptying pipes are negative. And for those complex problems, just think in work cycles. If you stick to these, you will sidestep all the common traps and have a clear path to the right answer.
Really, it all boils down to one fundamental concept. Efficiency is inversely proportional to time. The faster you work, the less time it takes. Once that idea really clicks in your head, these problems stop being tricky and they start to become second nature.
So now, you have the master key. You've gone from falling into the common traps to having a powerful system that can unlock pretty much any of these problems. So the only question left is, which problem are you going to unlock first? Go ahead, put it to the test.